Before I retire my proto board, I wanted to do another blink test. This is the output on RB2, and this is an input on RA0. The output is fed into a decade counter, and the output of the decade counter goes into 74LS00 just to drive the LEDs. I have another 74LS00 over here set up as an RS flip-flop, and that is toggling between my two switches that set it up for fast and slow mode. It's a lot easier to count how many times the LED blinks by counting how many times this cycles through. And so for 1 minute, this will cycle approximately 7 times with an extra 4 or 5 flashes. And that's in the slow mode. But in the fast mode, it's pretty hard to count this blue LED as it flashes. And you can see that the decade counter is actually showing it a little bit slower. So every time it gets to the end, that's basically 10 flashes. So you can just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 100, because it's a multiple of 10. I counted them, and I've figured that there's approximately 610 to 620 blinks per minute. And that's pretty much what this little board's doing right now. I have a flowchart, and I want to show that next. Here's the flowchart and assembler code. The first part of the code is the preset. This is going to determine how the microcontroller is going to work. The next part is the start of our actual program, and we want to determine the status on the input pin for RA0. If it's a 0, we make it slow, and if it's a 1, we make it fast. Then it takes those values and it puts them into the counter registers. The next step is to determine whether or not RB2 is set or cleared. If it's set, that means the LED is on, so we need to turn the LED off and we clear that pin. If it's cleared, then we set the LED on. The next is to run the delay. Counter 1 will loop through how many times the value 1 register was set. In this case, it can be FF or it can be 1F. To determine the delay for this test, we know that it was set to 2 megahertz. The 2 megahertz is divided by 4, which gives us 500 kilohertz, which is 2 microseconds. There are 3 cycles in here, so 3 times 2 is 6. It will do this how many times the register was set for, the value 1. So we have FF or 1F. If it's FF, then it's about 1.5 milliseconds. There are other clock cycles in here, but these are just rough figures. Then it subtracts 1 from clock 2 and checks whether or not it's gone to 0. If so, then it's done. But if it hasn't, it goes back and it does clock 1 again. To show the calculations of how many times it should flash, and it calculates out to about 75 on-off blinks in 1 minute. In the fast, 1F is 31 times 256 times our 6 microseconds, plus those delays end up being about 0.2 milliseconds. So it's somewhere in the area of 627. These are just guesses, they're not absolutes, and there's temperature variations and the chip isn't really going to be stable, but it's a close approximation. And as you can see from the video, that it was actually blinking very close to those rates. This has just been a a rough check to see how the lights will blink with the delay. I want to show interrupts in the future, so this code is pretty much done, and I'll be moving on to my next prototype. So hopefully I'll get that one out soon, and I hope this gave you some information, and thanks for watching.